Nvidia has the money. Nvidia has the demand. Nvidia has the most advanced AI chips on the planet. But right now, Nvidia is missing one thing, and it is the one thing nobody saw coming. Glass. Yes, you heard that right. The most valuable AI company in the world could get slowed down, not by a chip shortage, not by a GPU shortage, but by a shortage of glass. And not just any glass. A very specific, ultra-thin, ultra-precise material that sits quietly inside every AI server, every data center, and every future chip package that Nvidia is planning to ship. And right now, the factories that make this material have already sold out their capacity until 2027. If you thought the AI race was only about chips and GPUs, this video is going to change the way you see the entire industry, because the real bottleneck is no longer silicon. It is glass. And this story pulls in Nvidia, China, Taiwan, Japan, and the entire global supply chain all at once. So let's break this down properly. When people hear the word chip, they picture a small black square sitting on a circuit board. But that is not the full picture. A chip is never used alone. It sits inside something called a package, and that package is built on top of what is known as a substrate. The substrate is the layer that connects the chip to the motherboard, delivers power to it, and carries the signals in and out. For decades, these substrates were built from an organic, plastic-based material. That worked fine when chips were small. But once AI chips started getting massive, like Nvidia's Blackwell and the upcoming Rubin GPU, that old organic material started to fail. Here is why it fails. Every time a chip heats up and cools down, it expands and contracts.
Nvidia has the money. Nvidia has the demand. Nvidia has the most advanced AI chips on the planet. But right now, Nvidia is missing one thing, and it is the one thing nobody saw coming. Glass. Yes, you heard that right. The most valuable AI company in the world could get slowed down, not by a chip shortage, not by a GPU shortage, but by a shortage of glass. And not just any glass. A very specific, ultra-thin, ultra-precise material that sits quietly inside every AI server, every data center, and every future chip package that Nvidia is planning to ship. And right now, the factories that make this material have already sold out their capacity until 2027. If you thought the AI race was only about chips and GPUs, this video is going to change the way you see the entire industry, because the real bottleneck is no longer silicon. It is glass. And this story pulls in Nvidia, China, Taiwan, Japan, and the entire global supply chain all at once. So let's break this down properly. When people hear the word chip, they picture a small black square sitting on a circuit board. But that is not the full picture. A chip is never used alone. It sits inside something called a package, and that package is built on top of what is known as a substrate. The substrate is the layer that connects the chip to the motherboard, delivers power to it, and carries the signals in and out. For decades, these substrates were built from an organic, plastic-based material. That worked fine when chips were small. But once AI chips started getting massive, like Nvidia's Blackwell and the upcoming Rubin GPU, that old organic material started to fail. Here's why it fails. Every time a chip heats up and cools down, it expands and contracts. If the substrate underneath it does not expand and contract at the same rate as the silicon, the entire package starts to warp, almost like a plastic spoon left out in the sun. For small chips this was manageable. For today's giant AI chips, this became a serious engineering problem. And this is exactly where glass substrates come in. Glass expands and contracts at a rate that is extremely close to silicon, which basically eliminates the warping issue. On top of that, glass allows for more layers to be packed in, reduces signal loss, and even lowers the overall cost per package. This is such a big deal that Nvidia has already announced that its Rubin GPU, which is set to enter mass production in the second half of this year, will fully transition to glass substrates. Now here is where the real problem begins. Let's talk about that number in the title. 36 times. AI data centers need 36 times more glass fiber compared to a standard server. This glass fiber is often called glass cloth, and it is used as a reinforcement layer inside the substrate. This is not your average glass. It is an ultra-fine, high-precision fiber that only a small handful of companies in the entire world are capable of manufacturing. Think about that for a second. If a normal server needs 1 unit of this material, a single AI server rack needs 36 units. Now multiply that by the scale of data center expansion happening right now across Nvidia, Google, Microsoft, Amazon, and Meta, and you start to understand why demand has completely exploded. This is exactly why the world's leading manufacturer of this advanced glass cloth, a Japanese company that dominates this space, has already had its production capacity booked out months in advance. Companies are literally lining up and waiting their turn. And this shortage is not limited to one single company or one single material. Even memory chip makers like Samsung and SK Hynix have openly warned that AI-driven shortages in memory and materials could stretch on until 2027 and possibly even beyond that. This is not some small, temporary supply hiccup. This is a structural, multi-year shortage that has the potential to slow down the entire pace of AI development across the world. Now let's get to the most interesting part of this story, which is China. While American, Japanese, and Taiwanese companies are racing to expand their own supply chains, China has turned this glass substrate race into a matter of national priority. Chinese leadership has openly called artificial intelligence an epoch-making technology and made it a core pillar of the country's next 5-year plan. Several major Chinese companies have already jumped into this space.
China's domestic supply chain, on the other hand, can currently only manage 3 to 4 layers. That is a massive gap. It means that while China is investing heavily, building factories, and racing to catch up, the country's own chip industry leaders have publicly admitted that they are still 5 to 10 years behind when it comes to advanced AI data center chip technology. So what does sold out until 2027 actually mean in this context? It means that whatever limited high-quality glass material and advanced substrate capacity currently exists in the world, whether that is in Japan, Taiwan, or China, has already been fully booked. New orders simply cannot be fulfilled before 2027. And until China closes that technology gap on its own domestic capability, it cannot fully capitalize on this shortage to leap ahead. Right now, China is very much in the race, but it has not yet taken the lead. Now let's talk about Nvidia's actual exposure here, because this is where things get uncomfortable for the company that everyone assumes is untouchable. Despite being the most valuable company on the planet, Nvidia depends on Asian supply chains for more than 90% of its production costs. Chips, substrates, memory, and packaging all pass through factories in Taiwan, South Korea, Japan, and increasingly China before a single finished product reaches a data center. This is exactly why Nvidia's CEO, Jensen Huang, made personal trips to South Korea to secure deals directly with memory manufacturers. That was not some routine corporate visit. That was a supply chain survival mission. Think about the irony here. Nvidia has the best AI chip architecture in the world. It has a market valuation in the trillions of dollars. But if the company cannot secure glass substrates, glass cloth, or memory chips on time, its next-generation Rubin GPUs could get stuck right at the production stage. This is almost an exact repeat of what happened with high-bandwidth memory chips a couple of years ago, when demand was so extreme that even Samsung and SK Hynix could not keep up with supply. Now the exact same pattern is playing out with glass. And here's another detail that makes this even more serious. Nvidia's next-generation chips, Rubin and Rubin Ultra, are going to be significantly larger than anything before them. The Rubin Ultra package size is expected to be about 9 times larger than a standard reticle-sized chip. That means bigger chips need even more glass material, which puts even more pressure on a supply chain that is already stretched to its absolute limit. This is not just a Nvidia story or a China story anymore. This has become a full-blown global race, and pretty much every major semiconductor player on Earth has jumped into it. Intel has already unveiled its own thick-core glass substrate technology and is targeting mass production sometime in 2026. TSMC has built a pilot production line for something called CoPoS chip-on-panel on substrate, with small volume trial production expected in 2027 and full mass production expected between 2028 and 2029. Samsung is also developing its own glass interposer technology and has already built its first mini production line. LG Innotek is building a pilot line at its Gumi plant and is targeting mass production sometime between 2027 and 2028. And then there's Corning, the backbone of this entire industry, which recently unveiled a new optical interconnect component called Glass Bridge. Industry analysts believe that 2026 will be the first real year of commercialization for glass substrates, with the global market expected to reach around $18.6 billion, and growth potentially accelerating to a rate of 67% after 2028. These are not small numbers. This tells you that glass substrate technology is no longer some niche engineering detail. It has become one of the foundational battlegrounds for the entire AI hardware industry over the next decade. So what does all of this actually mean for you, the person watching this video right now, who probably doesn't work in semiconductor manufacturing? Here's the direct answer. If this glass substrate and glass cloth shortage continues at this pace, it is going to directly impact AI chip prices. That is going to impact cloud computing costs. And that is going to impact every single company that relies on AI, whether that's the AI chatbot you use every day, the AI tools your company depends on, or the cloud services running behind the apps on your phone. So the next time you hear that an AI subscription price has gone up, or that a company is delaying a product launch because of chip shortages, remember that the root cause might not even be the chip itself. It might be a small, brittle, unbelievably difficult to manufacture material that most people have never even heard of, called glass. And here's the part that really matters long term. Whichever company manages to solve this shortage first, whether that's Corning, BOE, Intel, TSMC, or some name we haven't even heard of yet, that company is going to end up controlling one of the most critical choke points in the entire AI hardware industry for the next decade. This is a race that is happening quietly, largely outside of mainstream headlines, while everyone is busy talking about GPUs and chip bans. But make no mistake, this materials race might end up being just as important, if not more important, than the chip race everyone already knows about. Let's slow down for a second and really sit with why glass, of all materials, became the answer here, because this part is genuinely fascinating once you understand it. Engineers had tried other fixes before glass entered the picture. They tried improving the organic substrate material itself. They tried adding extra support structures to prevent warping. They tried redesigning the packaging process entirely. None of it solved the core problem, because the core problem was physics, not engineering. Organic material and silicon simply do not expand and contract at the same rate when they heat up, and no amount of clever engineering can fully cancel that out once chips get large enough. Glass, on the other hand, naturally behaves almost identically to silicon under heat. It wasn't invented for this purpose. It was discovered to be the right fit almost by accident, the way a lot of major breakthroughs happen in engineering. And once that discovery clicked, the entire industry pivoted toward it at the same time, which is exactly why demand exploded so suddenly. This wasn't a slow, gradual shift. It was closer to an entire industry flipping a switch all at once, and the supply chain simply was not built to handle that kind of sudden pivot. To put the scale of this shift into perspective, imagine an entire global industry that spent the last 20 years perfecting one material, building factories around it, training engineers around it, designing entire manufacturing processes around it, and then suddenly realizing that material has hit a hard physical limit. That is essentially what happened here. And when an entire industry needs to pivot to a completely different material at the same time, you don't just need new factories. You need new expertise, new equipment, new quality control processes, and years of testing before anyone can trust that material at scale. That is exactly why even the most advanced glass substrate manufacturers are still years away from true mass production, despite how urgent the demand already is. This is also why the geography of this race matters so much. Glass substrate manufacturing isn't something you can just build overnight in any country with enough money. It requires an extremely specific combination of materials science expertise, precision manufacturing equipment, and years of accumulated process knowledge. That is why you see the same handful of countries showing up again and again in this story: Japan, Taiwan, South Korea, the United States, and now China trying to force its way in. Each of these countries already had a strong foundation in either glass manufacturing, semiconductor packaging, or advanced materials research, and that foundation is what allows them to even attempt entering this race in the first place. A country without that foundation simply cannot catch up in a year or two, no matter how much money gets thrown at the problem. And that is exactly the wall China is running into right now, despite its massive investment. It's also worth pointing out how unusual it is to see this level of cooperation between companies that are normally fierce competitors. BOEE partnering with Corning is a perfect example. These two companies operate in completely different markets, under completely different political systems, and yet they are working together because neither one can solve this problem alone. Corning has the advanced material science knowledge. BOE has the manufacturing scale and local market access. This kind of cross-border collaboration tells you just how difficult this technical challenge really is. When companies that would normally never work together are suddenly forced into partnerships just to keep up with demand, that's usually a sign that the underlying problem is bigger than any single company or even any single country can solve on its own. Now zoom out even further and think about what this means for the next 5 to 10 years of AI development as a whole. Every major prediction about AI, faster models, cheaper AI tools, more powerful data centers, all of that assumes a steady, uninterrupted supply of the hardware needed to build those systems. But hardware doesn't just mean chips anymore. It means memory, it means power infrastructure, and now it very clearly means materials like glass substrates and glass cloth. If any single link in that chain breaks or gets delayed, the entire timeline for AI progress shifts with it. This is exactly why so many industry insiders are quietly watching the glass substrate space so closely, even though it barely gets mentioned in mainstream AI news coverage. It might not sound as exciting as talking about a new chip release or a new AI model, but it might end up shaping the pace of AI progress just as much, if not more, over the next several years. So that's the full story behind Nvidia's glass problem, why this 36 times demand number is such a big deal, why China is throwing everything it has into this space while still being years behind on the actual technology, and why even a company as powerful as Nvidia is not immune to a supply chain squeeze coming from a material most people didn't even know existed until now. If you found this breakdown valuable, make sure you're subscribed because we're going to be covering the entire AI hardware supply chain story as it unfolds, piece by piece. And let me know in the comments, who do you think wins this glass race? The United States, Taiwan, Japan, or China? I'll see you in the next one.